Hello, everyone. The agenda doc is linked in the meeting invite. Please take a moment to add your name to the attendance. Cool. All right. I guess we'll get going. It's a slightly smaller group than usual, but it's also the summer, so maybe people are on vacation. Um, the only things that I wanted to cover in the agenda were just a quick update on some of the ModelPack tasks. However, I think I've seen your work, Sudong. So I know you're still working on Sneak. Thank you. And I think the rest of them are pretty much with me. And it was a busy week. I haven't had a chance to get too far on them. Mateo, I know, has opened some issues as well. Uh, the model hack logo design brief. I would like to get that submitted. So if there are any changes that people want, please get them in today or tomorrow before the weekend. And I will try and submit that logo request on Monday since it'll take several weeks for them to do it. Does anyone else have any things they want to discuss?
I think the sneak item has already been finished. I
Oh,
pasted
great.
the PR or the related PR in the bullet under the bullet.
Thank you. Sorry, I missed that.
Um,
All right. Thank you very much.
yes, but actually I don't know how to validate it. Actually, the PR is created by a CNCF guy, but you can check the PR for details. Mm,
Uh, it seems to show that it's already merged though.
yes,
So sorry, doesn't that mean it's done?
I think so.
Yeah, I think so too. So I think we're good. I guess we'll we'll find out. Awesome. Welcome, Emily Teo. Okay, let's jump back a second then. I'm just trying to get a little bit of a bead on how things are going with our CNCF onboarding. Um, Mateo, it looks like your work is, oh no, the PR is still open, but that's just a badge.
Yeah,
Um,
hi everyone. I thought it's like to follow up on the previous meeting. So I've created the badge. I've started to fill out some of the details. So this will be a work in progress for a while. And actually, sort of like maybe a suggestion is that for some of the maintainers, if they want to create the OpenSSF badge account, so it's like a best practice.dev. You can create an account that I can extend authoring right to the badge so that we can collaborate on those issues. And I've created done the PR that adds it to the README.
okay, awesome. So I think it sounds then, Mateo, like it's just kind of a wait and see. Um, is there more work we need to do?
There the way that we approached that one in Kubeflow is that it was more kind of like a recurring task, sort of
Yeah,
like I can tell you it's like I think that a lot of sections with times I can also fill. So what we did for Kubeflow Model Edges is like I've logged in an issue, like I'm going to write this in the batch so that everybody had visibility. And sort of like then there are some sections that likely will require some action to be performed on the repo, like about static static code analysis, dynamic code analysis, and this kind of thing that will take more time. But I think that until we don't have a urgency to complete it. So sort of like I think that is mainly to show CNCF that we are like onboarding on this topic.
Okay, good. Okay. Yeah, I think the rest of them are on me. And as I said, it's been a busy week and I haven't had a chance to move too many of these forward. So I will try and get a little bit more progress going before our next meeting. Apologies. I just finished saying, and I'll just kind of repeat it quickly, the logo design brief, and the meeting notes are in the meeting request, so you can kind of follow along, but the logo design brief, I opened a PR for it so that anyone from the community can comment. So far, there hasn't been any comments except a kind of ta-da from somebody on the note I pasted. So I would like to get this over to the design team next week. So if anybody has any comments or things that they want to add or change, please comment on that issue thread before Monday. And then Monday or Tuesday, I'll send it over to the CNCF team. Any questions on onboarding?
Yes, I want to know about the domain apply, the process. Who should take this item?
Oh, yeah. Thank you for calling that. I will take that because I started it. It turns out I went originally to the wrong place. I sent it to I guess I sent it to, I forget if I sent it to CNCF and it needed to go to Linux Foundation, or I sent it to Linux Foundation and it needed to go to CNCF. But anyway, I will do that as well. Yeah.
Thank you.
Yeah, no worries. There was something else. Oh, yes. For all the maintainers, there are a set of key documents in the onboarding thread, and those need to be read. If you have been a maintainer in a CNCF project before, then you've read them because you would have had to. So I know Gorkum has read them because we had to for KitOps. Mateo, I assume you read them for when you had to do, was it Kubeflow?
Yes, but I will just check it just to make sure that they are the same. Frankly, I have a bad memory, but I will make sure.
Okay.
Thank you.
All right. All right. So other maintainers, please take a look at those key documents. I think there's like 4 or 5. They're generally pretty straightforward. There's nothing too shocking in them. That's all I had. Are there other topics that folks wanted to discuss?
Just a clarification, maybe I'm not sure about these adding maintainers to the CSV via PR. Do we have an action item for each, or you're taking care of it overall?
I was just going to do it for everybody because it
Thank
just
you.
seems easier than having everybody do it separately.
Yeah, way easier. Thank you.
Yeah, no worries.
And last time I remember that Emily will, maybe I remembered it incorrectly, and it meant I'm not sure whether she is ready for an introduction for the works from Docker side.
Yeah, I'm ready to show you guys a short demo today, if you're
Nice.
interested.
Great.
Okie dokie. This won't be too long here. But my plan was to give you guys just a quick overview of the components that are in sort of Docker model runner in Docker desktop and Docker CE and how that ties into the artifact format stuff. Is there anything else that people are interested in while I'm going over this? I want to sort of understand what people's uh, curiosity is here. Like what are your big questions? What do you want to know about so I can make sure I talk about it?
I think one thing that would be cool, Emily, is as you go through, there are a couple things where I think you've said Docker is kind of taking a different approach than ModelPack spec. It would be cool to kind of know kind of where how those things manifest themselves, I guess, or if they do. It may all be, I guess, under the hood stuff, but
Yep, happy to do that. And as I'm going, feel free to interrupt me. Um, yeah. Okay. Uh, I adapted an old slide deck here. We can go through it really quickly just to give you an idea of what you're looking at before we show it. So this picture here shows sort of like the high
sorry,
level arc.
I think you might be sharing something different. We're seeing your ModelPack doc and maybe Slack or something.
Oh,
And
sorry. I'm showing the
yeah,
wrong screen here.
yeah, no worries.
Other desktop. Thank you for that. Okay. Do you see a repo and a terminal now?
We do.
Uh, great. Hold on. Hold on, give me 1 second. I've lost my view of the thing. I don't know what happened here. I've
Zoom lives to
is it
give you 1,000 options to have to navigate to do anything. It's really
I feel like I opened the slideshow and it appeared in a new desktop or something, and then it was the wrong desktop. Okay.
macOS loves to just throw those things up randomly.
Sorry for not showing it, but I'm like, oh no, I got some. Just want
Guess
to
it
make sure
doesn't
I'm
need
not
you to
showing
start
anything I'm not
Zoom
supposed
yet.
to be. Okay, let's try this one more time. I think we're gonna make it here. Okay. Okay. Desktop with one
big,
slideshow in it. Yeah, yeah.
yeah, big JSON.
Great.
Excellent.
Okay, great. Okay. I'm just going to go through this without sort of officially opening his slides because I don't know what it's going to do to me. Okay. Sort of an overview of the landscape here. The component we're mostly going to talk about today is the model distribution component, because this is sort of the piece of our architecture that manages models and the content store. So Docker Model Runner is a component that runs inside Docker Desktop or can run inside Docker CE. It then in turn uses an open source component that we call model distribution. And model distribution is like a repo that provides a client for interacting with a local store of models and for packaging models and pushing and pulling them to OCI registries. I think very similar to some of the tools you've worked on in this project. And then Model CLI is a Docker CLI plugin that then interacts with this API. So we have a tool directly in model distribution that allows you to play with these artifacts, but typically when Docker users are interacting with models, they're using the Docker CLI plugin to interact with the model runner component, which then under the hood is using the model distribution component. And model distribution is creating models that implement the Docker model spec. And this spec is, we'll talk about this more, but this spec has things in common, heavily inspired by ModelPack, but also inspired by what Olama is doing under the hood, because so far that's been the most similar use case to what we're doing. So our design goals in this were to make familiar workflows, people who are very familiar with Docker, to make models as approachable as possible to those people. So if you're used to finding, images to interact with on Hub, you can now find models to interact with on Hub. The Docker commands that you're used to using, we want it to be as similar as possible, even if under the hood, we're not necessarily running a container. We want it to feel familiar to people who are familiar with Docker. We want our spec to provide efficient access to metadata so that registries and tools can populate information about models like they're a first-class citizen rather than having that be, something that you're specifying in a label on a normal container or something that's just not accessible. And we want Docker Model Runner to be as performant as possible. And before we introduced this tool, people were typically running models in containers in Docker in ways that were slow. So you'd end up with, by default, I think you guys are really familiar with all this. I'll try to be fast. You end up compressing and uncompressing high entropy files, which is a waste of time. You can end up with multiple copies of these large model files, which is something that already exists in a container with a large file, but it's even more painful with models. So we wanted to make the experience of running models in Docker Desktop as performant as possible. Digging into the manifest, we're shipping these things as normal OCI artifacts. We're identifying the content of each layer by the layer media type. And you can identify the fact that this is a Docker OCI artifact by the media type of the config. You guys are all very familiar with this. Digging into the config itself, you can see it has a similar high-level organization to the ModelPack config, where we sort of have provenance information in the descriptor section, and we have metadata about the model itself in the config section. One thing that might be interesting about this is we're allowing, so right now, all of the models that we're packaging are GGUF files, because at the end of the day, Model Runner is going to execute these files with Llama CPP. So in the config section, we have this organized where, eventually we're probably going to support other file formats. So we have config in a generically accessible schema at the top that we believe will be the same across the formats we support. And then we're literally copying all the key value pairs out of the GGUF file and populating it in a format specific section so that, we don't know exactly what people are going to do with these things, and we want a break glass option to get at all of the raw metadata to enable the widest range of use cases possible. So this literally describes the GGUF file. Now, some of the settings in the file, like the default context length, when you're packaging, you can actually override that at the top. And then when the model runner runs the file, you'll get that default applied at runtime. And what's nice about this is you can create variations of the model without actually manipulating the GGUF file, because at the moment that's one big layer. So if you want to change that one value, all of a sudden you'd have another huge layer that you'd, most of it would just be duplication of all of your tensors just to change one context length value, and that's not great. So we're providing ways right now. Context length is an example, but things like template and other defaults that you can, similar to a container's runtime config, when you're packaging, you'll be able to change these at the top, and then the runner will respect it at runtime. The layers themselves are not file system change sets, because this is not a container at the end of the day. It's just a set of files, and the type of the file is identified by the media type. Every layer has exactly one file. They're always uncompressed. There's no option to compress it at the moment. And some of the nice things about this, like we already talked about the compression being an issue. The fact that there's no file system metadata here, like no file name, no mod time, no UID. Like it's possible when creating a container image to make sure that you're not changing some of these values and then, creating a new blob instead of reusing it. But if you don't even have the option to set these things in the blob content in the big blob, then there's no chance of you accidentally duplicating a bunch of tensors just because, you named the file one letter different. So then when we're pulling these things in Docker Model Runner, at the moment, everything is sort of like sitting parallel to the normal Docker stuff because we wanted to experiment and move quickly without, we wanted to learn and then figure out how to more deeply integrate it. So instead of pulling these models into the containerd content store or the Docker daemon content store, we're pulling them into like a directory where things are organized basically as an OCI layout. And then when Docker Model Runner is running these things, in the case I'm talking about, this is not like a Kubernetes case. This is a local desktop case. So Docker Model Runner is looking up the path that's literally in the content store on your host and just executing Llama CPP with the correct args. Eventually, we want to isolate these things even on desktop. How this works in Docker CE right now is that all of this that I'm describing is running on the local desktop is actually running in a container. And the models are then in a volume in that container. So it's like you can run it in Kubernetes, but it's not integrated into the system. It's more like layered on top. You create a persistent volume and attach it to the container and then use that as a way to provide your models in the future. So that's the like, current state of affairs, not the desired end state, but that's where we're at the moment. There are two APIs, high-level APIs provided by the model runner. One is like a API that's as similar to the Docker Engine API as possible, but with models as sort of like a first-class object. We try to make the usage similar whenever that makes sense. There are some differences in how these things are used, but in general, it's like a Docker Engine-esque API. And then we also provide OpenAI API in Docker Model Runner. So I'll just show you really briefly how this works. Okay. So I'm running Docker Desktop. I have some models here. I can run one of these. And what we're going to see is that this is going to actually, when I make this request, it's running Llama CPP, a version that's packaged with Docker Desktop. This can actually be updated out of band with Docker Desktop because we found that we need to keep updating Llama CPP to support new model families as they come out. So we've created sort of like a modular component to push out Llama CPP updates without requiring people to update Docker Desktop. Yeah, so we're basically just, running this. And you can see the content store that I was talking about. It's just all these files here. We're not then, like in containerd, you'd have your content store with all the blobs, and then you'd use it to create a container, and then you're on the container. At the moment, we're just passing these files directly through to create as few copies as possible. And yeah, so down here, I'm in model distribution. You can actually you can build this CLI tool to interact with the models directly if you want. It's not as, I think the CLI interface we've most focused on is the Docker CLI, but we sort of like explore here and want to make it available to folks that are using this outside of Docker. So we have this option. even if it's a little rougher in terms of like output and things like that. Let's see. So here I can package models. I could also do this. I can package models through the CLI as well, which is basically doing the same thing under the hood as what I'm doing with this distribution tool. And here's an example of me setting the context size. So then if I pull this one, so we can see this like server thing here. Let's try running this. I might not have pulled in the version of the server that supports the context size. I was expecting to see a context size argument here. There is a version of this that if you pull this down, will then respect it in the CLI arguments because it's sort of inspecting the config first. We could debug and figure out what exactly my issue is here. But I'm not sure exactly how long that will take. I think it might be that I haven't updated to the latest version of the server yet, so I apologize for that. But I think you get the idea. And yeah, we're working on adding more config options, things like templates. And we added multimodal projector files recently, although that's not sort of like released through the whole tool chain. You can at least add them in distribution. And we're working on adding adapters, and we're very interested in the idea of what we can do within index file. Like, we have the OCI artifact. Index of artifacts opens up a variety of options. Like, do you want to package different models with different quantizations so that based on the resources you can pull the right one? Do we want to package models in different file formats? Because unlike a container, it's not as nice that you can just run anything anywhere. It does matter the underlying hardware. So things like that we are thinking about. And yeah, does anyone have questions?
You were saying at one point that it's not very well suited for, like, it's more focused on desktop and less so on the Kubernetes use case. But have you played with the OCI artifact volume mount stuff in Kubernetes at all?
I have played with it a little bit, yeah.
Okay,
I
yeah.
think to directly do the volume mount now, like your artifact still needs to be a file system, right? Because at the end of the day, you need to
Yes.
mount a file system, and ours at the moment isn't. It's just something that's being run directly out of the store rather than turned into a file
Right.
system and then executed. But I was talking about deeper integration into containerd, and we're looking at how can we make this more integrated in the future. Like, can we, even if we're polling in the current format, can we then, with containerd shims, add a layer that knows how to translate that into a file system if that's what we want to run? And then like, how efficiently can we do that? Maybe we don't need to make a
Yeah.
copy. Maybe we can, point at the same files, do something clever there.
Yeah.
So if we had
Yeah,
that sort
I
of
didn't.
containerd integration, then you could do something in Kubernetes that's similar to like WASM, run WASI and runtime classes and blah blah blah. We're like,
Yeah.
what is the most deeply integrated version of this? But yeah.
Yeah. Yeah, I don't think I dove too deep into it, but I think it was about a month ago there was a thread, I think in the Slack, for ModelPack where there's the mount a container as a volume, but they've also, I think it was like recent versions of Cryo support mounting. I think Andrew and I ran through it at one point, but you can actually, if you have a OCI artifact that each layer is just a plain file, no compression, no tar, nothing,
Mm.
Like I think Cryo latest versions will happily just plop that into a volume and let you mount it inside a running container. So if you have like a
That
runner container, you could just stick your files right into it.
that is not something I knew worked, and I'm very eager to try that out because it would
I
solve a
didn't
lot of
try
my
it too
problems.
much, but it semi worked. I'll
pretty,
ping
Yeah.
you on the thread if you're on the
I'm pretty
Slack.
sure
Yeah,
that
thank
I'm
you.
pretty sure that we just high level got it working. Yeah, that Angel and I kind of went through. If you want, we can share our notes to setting up cryo locally through Kind. It's a good way to get started.
Yeah, I would appreciate that. Thank you.
Okay.
And just to confirm, so in your client, you still have Docker running in the background, and or the inference engine is created, the process is created by the Docker daemon, or is it created directly from the Docker client?
There are different ways it starts depending on where you're running. So in Docker desktop, it's starting the model runner on the host as a process, and it's just exposing this API. It's actually exposing it via the Docker socket, but it can also just expose it on a TCP endpoint. So it's not being run by the Docker daemon. In Docker desktop, it's always running next to the daemon because, desktop runs the daemon and it runs this, but it's really parallel. And you can actually go into the model runner repo, which is open source, and sort of run it totally separately on your host. You don't need Docker to run it. If you use that CLI tool I was showing you, and like you're in Docker CE, you don't have the Docker model runner process running on your host already, it'll actually start it in a container and then interact with it in that container. So it's either or. It's like either running natively on the host, so we have access to the macOS hardware directly, because the layers of virtualization in Docker Desktop sort of prevent efficient running of the model. But in a Linux environment where those constraints are different, if it doesn't find that the process is already listening, it'll start it in a container and then interact with it that way.
I see, that makes sense. And another question, in your model spec manifest is actually quite similar to the ModelPack one. And one issue we had when we are trying to package the model, for example, Hugging Face models to a ModelPack model image, we have to figure out a lot of these fields, and we actually have a script to do that, to help us do that. But I wonder how do you handle it in your case? Are you reading directly from the GGF metadata file, or do you have other ways to handle it?
Yeah, at the moment, because we're only supporting GGF files, the problem is somewhat constrained in that, we have the GGF file with the key value pairs in it, so we just parse it and then populate. We do have some scripts and tools in model distribution repo that you can use to take models on Hugging Face that are not already packaged in the GGF format and then package them that way in a variety of quantizations. And then it takes those GGF files and packages them in our OCI format.
So looking forward, then since these two specs are quite similar, can we look at how can we converge them? Because I believe that is part of your goal as well, so that we don't diverge on this one.
Yeah, I think we should make a step-by-step plan. In my mind, the first place we could converge is maybe the config JSON file.
Yeah.
Because I think, as I've mentioned in previous meetings, like we only support GGUF files. So I think we don't want to open ourselves up to saying we support the spec right now when many things that are packaged via the ModelPack spec we couldn't support because they're not GGUF files, or they're packaged as file archives, and we want to run at the moment in the way I just demoed you. But I think the metadata we could converge on first, and then from there work on the layers.
Yeah, I think most of the config.json design we share the same design, that we have common descriptions on the model, such as its
Yeah. It's not a coincidence
architecture for them.
because
Yeah.
we know we want to converge, so we've been trying to keep things similar where it's possible, right?
That's great.
Yeah.
And I think your idea of having a GGF specific section is interesting. Do you see other formats have similar needs? Because right now we mostly look at Pico and tensor. We don't see that need, but I'm not sure about other formats such as Onyx. Did you look at that?
Yeah, the short answer is I don't know. We've mostly been focusing on the GGF use case for now. And that section I showed you, we're not really using it anywhere, so maybe need isn't the right word for it, but we wanted it to be available.
I think we can look at it and decide later if we can have a common format specific field there, because in the OCI image we still have Linux section and Windows section, so I believe it's reasonable to have different format section as long as it can help the users. Yeah.
Does the model pack specification in the config tell you what format the files are in at the moment? The model file.
Yes, we have. I can even show.
Hello? Sorry,
Hello?
I didn't hear you.
Sorry, I forgot to
sorry.
share my screen. Let me do it. Okay, can you see my screen?
Yes.
Yep.
Yeah. So yeah. Emily, you're asking for this format field, right? Because we right now we are taking Onyx TensorFlow PyTorch here. A bit of safe tensor can be here as well. And we
Yeah.
share
I
the
think with
architecture.
that,
Yeah.
as long as we have that field, I feel like if you wanted typed data that's not consistent, if we just name the map after the field, then you'd be like, based on the format, then I can look up the format specific metadata. That's sort of how we've been thinking about it.
Yes. And another thing is, in your context case, we are putting to likely here in the model capability field, and we have there's input types, output types, knowledge that learning tool use, embedding, and reward. It serves the same purpose, I believe. But the layering design, I think it does make sense, because initially when we look at the model spec, when we first designed the model spec, we actually were thinking the similar that we have a base image spec and also a runtime spec building on top of it. And likely those should be combined in the same specification, but we will allow some kind of override so that the runtime engine can do different than defined in the model image. So I think we can together look at it together and this capability and more fields in that regard.
Yeah, one thing I don't love that we've done is we're sort of blurring these two concepts together. So like we're describing the model and we're providing overrides sort of in the same section. I feel like it would make
Yeah.
sense to split them out, and then that would help us describe what the support matrix is, because I think once you start adding overrides, if those overrides aren't actually affecting the content, but they're, a queue to the runner, like a runtime config, then I think maybe even versioning it separately. We might want to separate it and version it so that different runtimes can describe what they do and don't support.
Yeah. Yes.
So far, we've sort of been just kind of like Wild West adding things, and if someone's like, "Oh, this thing doesn't work," it's like just upgrade. But eventually, I think we'd like to be disciplined about the versioning, and I think that's a conversation be good to have together. Like whether the whole spec needs one version or whether we need to like version components, depending on, what we expect.
Yeah, but that's a very good point, Emily, that you brought up, right? It's like if I am like in the config file here, let's say that I have a value for a token size, right? And that's the token size, the context size, sorry, for the model itself. And that's the maximum context size that I can reach to, essentially, that defines what I have just packaged. But then if you want to override it, I don't think that should go into the same file, maybe. It's almost
Yeah,
like,
I agree. Or even if it's in the config file, we should probably break it out into a separate section. At the moment, we're sort of like, well, the GGUF file metadata
yeah,
has
it's,
the
yeah,
value that really describes the model, and then the config section has the value that should be used. But I think it'd be better to
yeah. But
split it out.
I was also thinking about the packaging because now I have the base model, let's call it a base model, which basically defines what is packaged. But now I want to be able to deploy that with a slightly different set of parameters. But essentially, I'm repackaging that because the config file has both. It's almost like a base. I need to think about it a little bit, but it's like a base and extent kind of relationship, maybe.
Yeah, I think the way I've been thinking about it for some of these defaults, well, if you're doing things like adding an adapter file or something, I think that fits really nicely in the base extend in terms of adding more layers. And maybe this is just a semantic difference, but I'm thinking about setting some of these things, like you want to change the default context size to be less than what's maximally supported by the model. I'm thinking about it as being similar to when you set runtime config in a container image. You're setting an environment variable or something like that. It's different. It's not the content of what's in the file system. It's, you know, the arguments to be run with
Yeah,
or the config to be run with. Yeah.
yeah, something like that. Something like that. Yeah. And of course, not all model uh, formats will support it, but, and that becomes another challenge for it.
Yeah.
That's a good point.
That's why I'm wondering if we break it into a section, you might want to put a version number in that section.
Yeah, and another thing we've been looking to internally is that we would like to describe the entire architecture of the model, such as how many layers does it have, what are the attention head, how many attention heads, or the super parameters, and it actually can describe most of the LM models in that sense. Does it make sense in your case? Can it help you better run your model?
I don't know that I can think of a case where we have a need for that at the moment, but I do think sort of anything that we can accurately describe is providing value to the user, just so they can understand better when they're, comparing different models, understand what they're running. But do you have a case where you're going to take that data and what's the case for using it?
Yeah, with that in our case is that when we look at the different inference engines, they actually have to adapt, have a modeling file for each of the category of the large language models. If you look at VM or SG9, they all have a lot of modeling files. Actually, we can abstract that have a common layer, and if the model is tagged in the common spec and with a common adapter, developers or users, they do not have to write their own modeling files. That's one use case we've been looking at. Yeah.
I feel like we're sort of piggybacking off Llama CPP for a lot of this, where they, have the logic built into Llama CPP for how to handle each architecture. But it doesn't feel as seamless as a container, right? You're like, oh, there's a new flavor of model. We have to update the engine basically in order to be able to run it.
Yeah, but that's a reality, right?
Yeah.
So very, very nice demo, and thank you, Emily. I don't have more questions. Thank you. We can work together and see how we can merge the specification and even more builds. Yeah. Thank you.
Yeah. Thanks.
Thank you all for your time and attention. I'm looking forward to getting these things more compatible. I think it'll be good for everybody.
Agreed. Any other topics from folks? Awesome. All right. I think we can wrap up. Next meeting is in 2 weeks, and I'll try and have a little bit more progress on my action items. And in the meantime, this is the kind of document that we do the notes and everything in an agenda. So obviously anyone is free to add to the agenda anytime. I'll add the stub for next meeting now, so that if folks want to add agenda items for next meeting, we can do that. All right. I will see you all in a couple weeks. Thank you.
Thank you, Emily. Thank you all.
Thank you.
Thank you, Emily.
Bye-bye.
Yeah,
Thank
thanks,
you all.
Emily. Thanks, all.
Bye.
See y'all.